You know, it's funny. Sometimes the biggest revolutions in tech don't start in some giant factory or a multi-million-dollar lab. Nope, they start with a blueprint, a model, something small enough to fit right on a desk. And we're going to look at one of those blueprints right now.
So take a look at this. At first glance, it kind of looks like a school project, right? Maybe something you'd see at a science fair? But what is this little machine actually built to do? What problem is it trying to solve? Well, the answer is written right there on the front. Now, unless you speak Vietnamese, you might not recognize it, but Automatiated Warehouse System translates to Automated Warehouse System. And just like that, this little homemade gadget reveals its secret. It's a miniature blueprint for pretty much the entire world of modern logistics. Okay, so to really get how this tiny machine mirrors these massive, massive operations, we've got to look inside. Let's deconstruct this blueprint piece by piece. First up, you've got the most fundamental piece, the storage grid. In this case, it's just 9 simple square compartments. This is the warehouse part of the system. It's just a structured space where you can store things in predictable spots. Next, we have the muscle. See this retrieval arm? It's on what's called a gantry system, and it's designed to do 2 things, but do them very, very precisely. Move side to side horizontally and move up and down vertically. This is the part that does all the heavy lifting. And finally, we get to the most important part, the electronic brain. Now, what's really cool here is you can see the cluster of wires and the circuit board. This is the command center. It's what takes an instruction and turns it into electrical signals that tell the motors exactly where they need to go. So we've got the parts, right? A grid, an arm, and a brain. But how do they actually work together? How does this thing think? Let's break down the logic. You know, the logic is it's beautiful in its simplicity. First, the brain gets a command like, hey, go get the item in the middle bin. Second, it moves the arm sideways to the correct column. That's your X coordinate. Third, it moves the arm up or down to the correct row. That's your Y coordinate. And finally, it grabs the item. That's it. Simple. The best way to think about it is it's basically a real-life game of Battleship. You don't just search around randomly for the other person's ship, right? No, you call out a coordinate, B4, and you go directly to that specific spot. This machine is doing the exact same thing, just with storage bins instead of battleships. Okay, and this is where it gets really fascinating. That simple battleship-style logic isn't just a neat little trick for a desktop toy. It is the fundamental principle that lets us scale this model up, from a little blueprint to a skyscraper-sized operation. I mean, just look at this comparison. Our model? It's got 9 little bins. A modern fulfillment center has millions of them. Our model fits on a desk. A mega warehouse can cover acres and acres of land. And our little guy has 1 retrieval arm. A real facility has whole fleets of robots, all working together. The scale is it's on a completely different planet. But, and this is the absolute key, the logic underneath it all, it's identical. Whether you're navigating a grid of 9 bins or 9 million bins, the process of getting a command, moving to an XY coordinate, and grabbing an item is exactly the same. The complexity comes from adding speed and scale, not from changing that core idea. So, why does getting to know this little model actually matter? Well, because when you understand its simple logic, you start to understand the engine that powers our entire modern world. This system, just scaled up 1,000,000 times, is what makes global e-commerce possible. It's the reason you can click a button online and have a package show up at your door the very next day. This kind of automation boosts efficiency, it makes workplaces safer by handling all the repetitive tasks, and it has totally revolutionized global supply chains. And it all comes back to the simple principles we see in this one little machine. So it really makes you think, doesn't it? If this one little prototype holds the key to a global logistics network, what other small models sitting on desks or in garages right now are the quiet blueprints for our future? What's the next big idea that's starting small?